But every now and then when it comes into like, should that grade round up to a 70? So the things I look at. Who's had integrity? Who's had? All right, ladies and gentlemen, a polynomial is a function with numbers and variables where the exponents are all whole numbers. And what that means is no negatives. That's what whole numbers are. Your whole numbers are 0 to infinity with no fractions in there. So by claiming whole numbers, we can't have any negatives. And we'll take a look at what that, why they put that definition in there. And the coefficients are real numbers. Now, this isn't how I introduce it to my freshmen. I don't talk about negative exponents necessarily with them because they don't make that transition in the Algebra 1 book. And I definitely don't talk about real numbers. You guys need to keep in mind that because now that we've introduced imaginary numbers in Chapter 5, here in Chapter 6, when they ask me, is something a polynomial, you've got to be looking for those imaginary numbers or square roots of negatives. Standard form, if we go through that vocab, standard form is we list the polynomial from largest exponent to smallest. And you guys are already familiar with that because we talked about standard form of quadratics. And we talked about our standard forms of quadratics. We started with ax squared plus bx plus c. We had the x squared first, then the x, then the c. So we're doing the same thing. The degree is the largest exponent. And I'll put the value of that largest exponent. So our quadratics had a degree of 2. Now, second degree, or degree of 2, have a special name, and those are quadratics. And if you guys look at the chart, we kind of go through those there. The leading coefficient is the coefficient of the first term. All right, does that make sense? It's leading, it's in the front. But what I need to be able to remind you is that it has to be in standard form. All right, you guys do a little bit with this today in your assignment. We really talk about degree and leading coefficient and why those are important to know when we look at tomorrow's lesson. Notice 6.2 is split over 2 days. So we introduce a lot of this vocabulary now, and then we're going to start using more of it and identifying more of it tomorrow. All right? Are we okay with that vocab, guys? Am I going slow enough or giving you guys enough time to read? Okay, so let's take a look at the last one. The constant term is the term without a variable. And you guys should know that. Constant was our C. Okay. Our constants actually have a degree of 0 because there's there's no variable in there, which means the degree was 1. So let's take a look and keep going with what we have set up here. All right, we're going to go through and list some of these names. If it's a 0 degree, the type is going to be a constant. And so those are your numbers like 3, negative 14, 12.9, and we'll call it 8.9 instead of 9.8. They just have no variable. They can be positive, they can be negative, they can be fractions, they can be decimals. But they have to be real numbers. They cannot be imaginary numbers here. So now we're going to leave those negative square roots and negatives behind. We're going to leave those imaginary numbers behind and just be focusing on these real numbers. Linear is what we graphed in the first marking period, so we kind of think of that as y equals mx plus b. So 3x plus 2 would be an example of a linear. The most we can have is 2 terms. All right? We could have negative 7.1x. So it could also be just 1 term, kind of like our constants are. But these will always have an x in there, nothing more than an x. Quadratics are what we're most familiar with because that's what we worked with in chapter 5. So if we had like negative 16t squared plus 40t plus 3, that dropping of an object or launching of an object, those are quadratics because the largest exponent is 2. Okay, and when we look, we have it written in standard form there. The exponent doesn't have to, the largest exponent doesn't have to come first in order to make it a quadratic. So you need to make sure that if they don't ask you to put it in standard form, you need to make sure that you're looking through and finding where is that largest exponent. Hopefully you guys are seeing the pattern here and can maybe make up your own. But for a cubic, something like 2x to the third plus 7. All right? It can have one term, it can have just an x to the third, it can have 2 terms, it can have the cubic and the constant. It could have all 4 of these terms. So we could have x to the third minus x squared minus x plus 1. You could have all of them. As long as that largest exponent is 3, the name you're going to give it, the type is going to be cubic. And then for quartics, it just means our exponent is 4, so something like x to the 4th minus 16 is an example of quartic. Now the reason we stop here is because these are really the ones that we give the most the special names to. Now as you go through, we have a quintic, we can go through and use our prefixes that we know for numbering. But the reason we focus on these, ladies and gentlemen, is because in chapter 5 we factored quadratics. Chapter 6, we're going to learn how to factor cubics and quartics, and we're going to stop at those. We're not going to factor 5th degrees, we're not going to factor 6th degrees. So we kind of do a review of what those look like and what those are, okay? We're going to be factoring special cubics and special quartics, and we'll get into that next week, but I just want to let you guys know why we stopped there for this chapter. All right, so now what we want to do, we're going to take a look at example 1 and 2. We want to decide whether each function is a polynomial function. If so, write it in standard form, state the degree, the type, and the leading coefficient. I noticed, ladies and gentlemen, that my notes are dated 2014. So even though I've been teaching this class for about 7 years, I've had my smart board for about 4 years, for some reason I changed these notes last year. And the reason I changed that here is because I want this to match what's in your book, okay? Do the directions match on your notes? Did I change them on your note handout, guys? Is that what's on your note handout? Okay. So this is what you're going to be asked to do. So the first thing I need to decide is, does this fit the form of a polynomial? Well, are all of my exponents positive? Yeah, as long as they don't have negative exponents, then yes, it is a polynomial. Once I say yes, guys, I have to put it in standard form. So what is the largest exponent? The 4th. So that means negative 5x to the 4th needs to come first. Then I need to go down to the smallest exponent. So then I have 3x squared. And then your constants are always going to be last. Those are always your last term because those have an exponent of 0. It said to state the degree. So the degree is 4. The degree is just the value of that largest exponent. The type is where you've got to flip back or look up to that chart. For 4th degree, what was the name that was given there? Quartic. And this is what I use to remember. How many quarters are in a dollar? 4. Okay, if you split something into quarters, you split it up into 4 parts. My daughter says to me, Mom, are there always 4 quarters in a basketball game? Yep, honey, that's why they call them quarters. Are there always 2 halves? Yep, that's why they call them halves. Like, get used to those names. And then last but not least, the leading coefficient. You're going to take that, and your leading coefficient is negative 5. So use what you know, guys, to help you remember these names. I don't give you a word bank. At this point, I expect you guys to recognize quadratic, cubic, and quartic. You should know linear and constant. So that chart you need to memorize there. All right? Any questions on the first one? Eric? Are you sure? Okay.
Do we have you have the degree, do you have the type?
Yep, the type is quartic.
Okay.
They don't have them listed with binomial or type. They don't have them use number of terms. They just have to list the type. Yep,
Four.
beta 7 was 4, and then quartic. They only focus on exponents here. Where in algebra 1, we had to do quartic trinomial, is what we would have done.
Okay, well, the 4 is
Yep, degree, that's why we said degree is just the value of the largest exponent. So the largest exponent is 4, so it's a 4. Then the type is the special name that we give it. So it's kind of, it seems almost redundant, but it gets them focused on where they're at.
Okay.
All right, example 2, ladies and gentlemen. Is it a polynomial? Well, do I have any imaginary numbers? No, but do I have a negative exponent? Yes. So this is not a polynomial, and you're done. All right? So what I would like you guys to do is open up your books to page 333. I would like you guys to do number 18 on your own. All right, ladies and gentlemen, let's take a look here and see what we have. All right. One of the first things that people notice is because they see a square root right away, they want to say no and move on. But remember we said it had to be a real number, so I said no square roots of negatives. Am I taking the square root of a negative here? Oh, it's a square root of a positive. So yes, this is a function. So now or a polynomial. So now I'm going to take a look at the largest exponent is 2. All right, wait, it said to put it, does it tell you just put it in standard form? Yep, write it in standard form. If you look here, ladies and gentlemen, this is standard form. It starts with the largest exponent. If you want to rewrite it so that the square root of 2 comes first, you can, but there's no need to. This is standard form for that. So if you left it the way the book has, it's fine. If you move that square root of 2 in front of it so that it actually looks like a coefficient, that would also be fine. It then says to list the degree, so the degree is 2. The type is quadratic. And now that I've gone ahead and moved that square root of 2 in front of it, now I can see my leading coefficient, and my leading coefficient is square root of 2. So be careful, guys. It's square roots of negatives and negative exponents that make our polynomials or make our functions not a polynomial function. Okay, so does that help clarify a few things there, guys? Any questions on what we need to do with those? You've got your 4 steps. Are we okay? All right. Let's take a look now on the back side, and we're going to talk about synthetic division. Or, I'm sorry, synthetic substitution. I mixed those two up, guys, and it's pretty common because the methods for synthetic substitution and synthetic division are exactly the same. What happens is what I'm looking for at the end and how I use the end of the problem. Synthetic substitution is basically a way of plugging 2 in for each of these x's without having to use my calculator and without having to do that math. Now, some of this is a little bit archaic, guys, because of the fact that you have calculators readily available. And when I was in high school, not everyone had them. It was pretty cool that my high school teacher had a graphing calculator. It was very old, not nearly as nice as what you had. So the point in teaching the synthetic substitution isn't really necessarily giving you another way to do substitution, because I know you can all do that. But what it does is it leads us up to what's called synthetic division. In the synthetic division, I don't have a shortcut for. There isn't something that the calculator can do for you. So we have to be able to learn synthetic division. And the synthetic substitution that we're going to learn here leads us up to that, okay? So realize that if you're struggling here, guys, you can't just go back to your calculator and do the substitution. You've got to learn this process, okay? What we're going to do is we're first going to make sure that it's in standard form, okay? Is this polynomial in standard form? Yeah. Then what we need to make sure is that we have every degree. So the next thing you need to do is make sure you have every degree. And so what I mean by that is I have x to the 4th. Got it. After x to the 4th, I should have an x to the 3rd. Got it. After x to the 3rd, what should I have? X squared. And do I have one? Yeah. After x squared, guys, what would we have? We would have an x. Do we have any x here? No. So I have to add that in, but you've got to add it in with a 0. We normally don't write down when we have 0 x's. The publishers don't print when we have 0 x's. But for synthetic division, you've got to put in that you have 0 x's. So then you're going to list with 0 anything that's missing there. Okay, guys? But we're not done. After x comes our constant of 1. So you need to put that in that plus 1. So that's where this chart, guys, is going to kind of come in handy, because you can go back and say, okay, I've got 4, 3, 2, 1. Oh, I need to remember to have my constant. You've got to go all the way back through those. Okay? I think one of the hints that we've done in the past, is that if I have a 4th degree, I have to have 5 terms. You're always going to have one more than that number. So I have a 4th degree. I've got 1, 2, 3, 4, 5 terms. I know I have everything. If you don't get that 0x in there, guys, we're not going to get the correct answer, so you need to make sure you have that. What I do is I then pull off the pull off the coefficient, sorry. And so that means I'm just focused on the 2, the -4, the 1, the 0, and the 1. And notice, guys, I left some spaces between them. Okay, we don't want to cram it all into one number. And so we've used everything from the polynomial that we can. Now what we need to do is use this x equals 2, what we're actually substituting with. And so what I do, and different teachers do it different ways, I make like an upside down division box. Okay, guys? It just helps me kind of square things off. And the x equals 2 goes on the outside of it. So what you're substituting is on the outside. The first thing you're going to do, and I would draw this arrow in here, guys, because this seems to be one of the first questions we ask. Where does that number come from? What am I adding? If you draw that arrow in every time and have it to look at, you're going to know what to do. This 2 simply comes down. All right? Once you've pulled off your coefficients, once you've pulled out the leading coefficient, then what you're going to do is multiply. Okay? So what's 2 times 2? 4. And then we're going to add those together and get 0. So then you're going to multiply, put it in the box, and then you're going to add to put it out of the box. So we multiply, that product goes up there, we add those together, and it comes down. What's 2 times 0?
0.
0. We put it into the box, now we add it together. What's 1 plus 0?
0.
1. We're adding. Remember, inside the box you add, outside of the box you multiply. 2 times 1 is 2. We multiplied and brought it inside the box. We add those together and get 2. 2 times 2 is 4. That goes in the box, and 1 plus 4 is 5. This last term you're left with, ladies and gentlemen, is the solution to that substitution. So when they say when x is equal to 2, we know f at 2 is equal to 5. Now, like I said, nowadays it's pretty easy. When I was in school, you had to do a lot of it with mental math or little calculators, like the ones I keep on the corner of my desk. And so this was pretty handy when I was in school. It was a quick way to do your substitution. You guys can always check your work before you turn a quiz or a test in to make sure that you're getting that 5 there. Okay? So let's take a look at one last example. I'll do a split screen here, guys, so that you can see what we're doing there. The first thing we did was make sure it's in standard form. Is it in standard form? Yeah. Now I need to make sure I have every degree. So I have an x to the 5th. After that, I should have x to the 4th. Do I have an x to the 4th? So how am I going to write that in my problem? With the 0. So plus 0, x to the 4th. If it's not listed there, that means there's 0 of them, but I have to list it in there. After x to the 4th should come x to the 3rd. After x to the 3rd should come x squared. After x squared should come x. And then if you go back to the chart, guys, on the front side, the very last thing is your constants, meaning that there's no, do we have a constant yet in this problem? So you have to put plus 0. Every polynomial that we work with, guys, has to end with a constant, even if it means you add a 0. Okay? So are we okay with where those two red terms came from? All right. Nate, I've got 5. What comes after 5? You're counting backwards. What comes after 5? 4. Were there any x to the fourths in this problem? So you have to add it in there, and you're going to add it always with a 0. Okay? After 4 comes 3, 2, and then 1, and then we said you always have to end with a constant. So it's just making sure that I can always count backwards. 5, 4, 3, 2, 1, and then my constant at the end. Okay? After that, it says to pull off the coefficient. So what coefficients am I pulling off? What's coming from the x to the 5th? -1. I know the cursor was in the way, guys. Sorry. 0. Then -4, 6, -1, and 0. What do we do next? Make our box. What number is going to go on the outside of the box? -2. Need to pull out the leading coefficient, guys. That's what this red arrow is for. So that leading coefficient has to come out. You've got to get something out of that box so that you can multiply by. So here's a -1. Who thinks they have the next step for us? -1 times -2. Good job. -2 times -1 is a 2. What number is going to go here? 2 plus 0. Good job, Jalen. And that's a 2. What's going to go next? And 2 times -2, which is a -4. That goes up here. Let me draw our arrow to bring them together. So that should be a -8. Don't be afraid to use a calculator if you need to, ladies and gentlemen. This should give me 16. Am I correct? So watch your signs. 6 and 16 is 22. And this is where, guys, we do start to get some larger numbers. So some of you may need to pull out your calculator a little bit sooner. We get -44. Add those together, we get -45. And then this should be a positive 90. Remember, you have to add those together, so 0 plus 90 is a 90. You're going to write your answers with f of -2, so you're taking what you substituted and then what it equals. It's always this last answer outside of your box, so f of -2 is 90. I want to see you guys set one up on your own. So you're going to go to page 334 and do 38. Now you are doing some problems in between there, guys. That is the first one, but you need to leave room for 20, 22, 24, and 26 after we did number 18 together. Okay? So get that done. Raise your hand and Mr. Clement and I will come around and look at your answer, check your work.
For example 4.
Yes.
So since if that was a -90, we still take -90.
Yes, whatever that end term is, positive or negative, we end up with there. And I'm trying to think. Actually, I don't think in your homework tonight you get any negative answers. That is kind of odd. But yes, you would use whatever is there. Oh wait. Wait. No, tonight's homework you do get some negative answers. I'm sorry, I was looking at the wrong section.